Okay guys, today we're doing 3.5 second derivatives, and we're also going to do derivatives with a table because both of these ideas are pretty simple, so we can get them done in one lesson. Let's go forward. Okay, first thing, I asked a question on the homeworks, and I've been getting some questions about how to do them. So remember before when we were doing first learning derivatives, and we would have to do them the really long way, and as the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, well, and then you would have to plug in everything you needed, the x plus h into the x's, and you have to manipulate this whole numerator to cancel stuff out. Okay, so right here I'm asking you to evaluate this. This is doing it the long way. Now, but you don't have to do it the long way anymore because you know the shortcut. If you just knew what the function was, you could just use the shortcut. Well, look at this thing right here. You do know what the function is. It's right here at the end, minus f of x. Right here. There's our function. Use the shortcut on it, and you know what this whole thing is evaluated. So let's do the shortcut on it. Well, bring down the 2, 12x. That's going to be plus 2, and the derivative of any constant is 0. So, there you go. If you would have done all the long process on this, it would come out to 12x plus 2. I mean, I don't want to do the long process, so I use the shortcut. Let's try it again on one other one. Okay, let me grab my pen. Now you can do it the long way if you want. You would have to write this out 3 times. You would have to distribute FOIL a lot. Or you can just look at the end and say, well, that's where my f of x is. Circle it here, and let me do the derivative of it. Bring down the 3, that'll be 24 x squared plus 10x, and there we go. If you did the long cut, you'd get to that. We did the shortcut, got it nice and quick. Okay, let me show you some of the new stuff. Okay, all you're going to be doing today is what's called the second derivative. It's pretty self-explanatory. We're going to take the first derivative, and then we're going to take the derivative of that one. So, let's start it up here. I started us off with a really easy one. First derivative. It's going to be 21x squared minus 6x, and that's going to be 0. So there's my first derivative. And I bet you can't guess on how we're going to denote the second derivative. We're going to put 2 primes. Yeah, f double prime equals. Take the derivative again of each one of these terms, one by one, right? So 2, so that's going to be 42x minus 6. Said find the second derivative, and that is it. Nice and simple. Okay, now let me show you how you would denote or show, represent the second derivative. We just used this method right now. You can also write y double prime, and this is how to write it in that dy over dx form, d squared y over dx squared. Okay, that means second derivative. Okay, now I'm going to show you how to do the derivatives with tables here. Okay, we're just going to take the derivative of this stuff. Now, these are really, really easy, but people make them complicated. And let me just do one example real quick over here. If I had the original equation 2x, and I was taking the derivative, it would be 2, right? I'd keep that number in front. Or let's even make it different. If I put a 3 on that one, this would be 2 times 3x squared. And that's how we're getting 6, right? 3 times 2 is 6. This is the same thing, right? Okay, so when we're doing the derivative of something like this right here, okay, we're going to label that we're taking the derivative of f prime. Notice the coefficient stays with it, right? So this 5 is going to stay with it. Then we're going to take the derivative of this. These are really easy. The derivative of h is just h prime. You can't make it any easier. And it says find f prime of 2. So here, let's denote this correctly. F prime of 2 is equal to 5 times h prime of 2. And 5 times h prime of 2 is pi. There we go. The answer to that one is 5 pi. Okay, let's do the derivative of this one. Your coefficient stays. Take the derivative of g. Well, that's simple. G prime. Nothing difficult about that. So let's find f prime of 2. It's going to be a half times g prime of 2, which is a half, times g prime of 2 is 5, which is going to be 5 over 2. Okay, the derivative of this one, the derivative, it's a constant. It's a constant, right? Remember, the derivative of any constant is 0. Okay, let's come down here. And you know what? I was noticing on the homeworks, people were having problems with this. I'm going to throw a little curveball in here. Let's throw a +3 at the end here. Okay, take the derivative of this. Remember, we take the derivative of each term separately. Derivative of this term is 2g prime. I know, this is difficult stuff. Derivative of this, keep the coefficient, 3h prime of x. Sorry, that doesn't look like a prime. Okay, and then the derivative of this is 0. It gets lost. Now we're checking it at 2. It's going to be 2 times g prime of 2, which I'm just going to skip forward. It's 5. Minus 3 times h prime of 2, which is pi. Okay, well, we got that is going to be 10 minus 3 pi. We're good to go. That's it. And you know what? I'm going to go back and do one more second derivative that has fractions. Okay, so I'm going to come back here where it's asking to do the second derivative. I'm just going to give you another example so you have 2 ones to go off of. So you can title this one example 2 for second derivatives. Let's say we start out with something like I don't know, 1 over cube root of x. People are having huge problems with this, so let's do an example like this. Okay, remember, first thing we need to rewrite it. That's the same as x to the 1/3, which is the same as, and you need to bring it to the top so you can take the derivative, negative 1/3. Okay, now I have not taken any derivatives, all I did was rewrite it. Now I can take the first derivative. Okay, remember I bring this down, so I'm going to have a negative 1/3. Remember, I'm making that line long because I'm going to keep the x on top. Okay, remember, you do negative 1 minus 3, negative 4 over, keep your denominator. There's my first derivative. Now, normally I would rewrite it because I don't like negative exponents, but I'm going to take a second derivative. So why rewrite it yet? Because I'm just going to have to rewrite it back to this so I can take the second derivative. So I'm just going to leave it like this so I can take the second derivative. Okay, I'm going to bring the negative 4 over 3 to multiply with the front here. So negative 1 times negative 4 would be 4 over 3 times 3, 9. So now it's positive because the negative is multiplied. Okay, and then we got our new exponent. Negative 4 minus 3 would be negative 7. Keep your denominator. Okay, this is the second derivative. I just need to rewrite it. It'll be 4 on top, and I'm going to move this whole thing to the bottom. 9 to the x. Now it's going to be positive. And what people are really bad at, let's rewrite this. Remember, the denominator is the root. So I'm going to have 9 cube root of x, and this 7 stays as an exponent. And that would be the second derivative. There you go.